Hi guys, good morning.
Good
Guys,
morning.
am I audible? Yeah, good morning. Sorry, I forgot that I had a demo today, so that's the reason there was a confusion in the morning. Okay, so sorry for that. Let me share my screen. Okay, so before we start the hypothesis testing, is any question regarding the Python code which I have shared yesterday, or any question related to probability and probability distribution? Not responding, I'll take it as no. Okay, so let's start with hypothesis testing. Okay, we also call as statistical testing. So how many of you have heard this term hypothesis testing? You may have heard this some or the other place. So have you guys heard this word hypothesis testing or not? Yes or no?
Yes,
Okay. So where have you heard this, and what do you think this hypothesis testing is all about?
I mean something new or somebody's trying to do some kind of uh, testing on new thing or which is unknown yet.
Okay.
They're posing like an idea.
Okay. Right. Any other view? So first of all, let's understand this, okay? What do you mean by hypothesis? As a word, what come into your mind when you hear this word hypothesis? So it is derived from a word like hypothetical, right? So what do you think this hypothesis could be?
It's like whatever you assumed, you're trying to test that.
Right. So hypothetically, we assume certain things, okay? There's a reason we call it as a hypothesis. And in data science, wherever we have to solve any problem, okay, we assume certain things, okay, that this is something, okay, we need to prove, okay. And based on that, we go and formulate a problem and then we go and solve that particular problem. So here also, it's not something like we assume anything. There has to be a scientific way of assuming certain things. So we will understand that how we can define these hypotheses. Okay. Once we define those hypotheses, then we go and test those hypotheses. So hypothesis, let's suppose I'll give you an example. Okay. Now I want to prove that, okay, this particular medicine would work for this kind of disease. So that is the kind of a hypothesis I'm making. That is not been proved yet. Okay. It is altogether a new hypothesis which I am coming up with. So now to prove that, now you tell me, how can I prove this? I'm saying that this medicine which I have discovered will work, and will help, to heal this kind of disease. Now you tell me, how would I prove this hypothesis? Guys, let's make it more interactive, guys, because I'm getting bored, just when I am only talking. Okay. Let's make it more lively. Okay. So let's answer my question. Okay. So if you have to prove something, how you will prove to somebody?
So we'll take a sample and we'll try to check, whatever we assume, whether that holds true or not. So then we
Yeah,
need to know.
in a very layman terms, if I have to prove somebody, I will test it and I will show it. See, I was saying that this medicine will work, right? See, I'm testing it, or else you only test it, or I will test it, or I will give it to somebody else if that person is having that problem. And if it worked, then I'll say that now see, okay, whether my hypothesis, whatever I made, the statement, now you only have to agree that whether it is true or not. Right? So basically, to prove my hypothesis, I have to do the testing, right? In the layman terms. Now, this is the same approach. We will do it by some scientific method in statistics, using statistics, and that we call as hypothesis testing. Okay. So now let's understand in more detail. 5 sliders. Yeah. So what all steps we need to follow, to do this kind of hypothesis testing? Firstly, we have to develop the hypothesis. In this kind of hypothesis testing or statistical testing, we generally make only two hypotheses. One we called as null hypothesis, so second we call as alternate hypothesis. So in this class, we are going to discuss about what is this null and alternate hypothesis and how we develop these null and alternate hypothesis, because that is the first step what you have to make. Before, see, when you have to test it, you should know, right, for what you are testing and what you have to prove, right? So this is the first step. We have to frame the null and alternate hypothesis. Now, after that, we will understand if the test comes out successful, okay? And if I take the decision based on that, is there any chance of me making any error? Now, for example, this example only, I gave that medicine to somebody, and let's suppose that person got healed by that disease. It may be a chance that, okay, that person has already taken some other medicine and that has worked and my medicine didn't react, okay, but I'm assuming that my medicine worked. Or else, he has done something, or he has consumed something else, or by the time, he has taken my medicine, by itself, that particular problem, got resolved automatically. So if I am agreeing, saying that your medicine is, yes, effective, am I making any error? Even if I go and reject, saying that your medicine is not effective, am I making any error? Am I taking the wrong decision? So if you put it in a business term, let's suppose a new product is getting launched. Okay. If I reject that based on the test results that no, this product cannot be launched, am I making any error by making that decision? So like that, by rejecting or accepting something, I will make two different kinds of errors known as type 1 error or type 2 errors. So we will understand like what is the type 1 and type 2 error. And for any hypothesis testing, we need to understand which error would be more critical, more dangerous. Okay. And we'll try to minimize those errors while making the decision through this hypothesis testing. Then again, what are the different types of testing we can perform? Okay, through this hypothesis testing, we can perform the test on the mean, okay, and on the proportion as well as on the variance. So variance we will not cover in this course because it is comes under more advanced concepts. Okay, but we will talk about mean and proportion. So why we kind of do this hypothesis testing? So for example, in the drug case only, example only, if I have to approve a particular drug, I cannot go and first try it on the entire population, right? It doesn't make sense also. If the COVID vaccine is coming, okay, COVID, I don't take that vaccine example because that has to be applied on the population. For example, some vaccination related to hepatitis B, right? So it is not required for entire population. I will not go and try that entire vaccine, on entire population, right? And then say that, okay, now this particular vaccine is effective. And what's the point? Okay. So if it is not effective, the entire population will suffer, right? So what I have to do is I have to go and take some sample. The way in clinical trials it happens is that first the drug will be tried on some animals, okay, on some other creatures, and after that it will be applied on the humans. And again in the humans, we will take certain sample, certain humans of different age group and gender, and then we test those drugs on that. So it will be performed for any drug which is kind of uh, which is not what do you say, not that fatal, okay. Or if it is based on that, we have to decide on the number of clinical trials and number on the sample. If If it is like fatal, if it is like life-threatening kind of vaccine, then it has to go through with multiple trials. And even the samples, like when it is getting tried on the humans have to sign everything like, okay, this is I'm participating in this particular trial uh, voluntarily. Okay, if anything happens, I'm not responsible. The company is not responsible. Everything will get signed. So, so what I meant to say that, okay, when you have to make a decision for the entire population, and if it is not feasible, and if it does not make sense to try it on entire population, we'll try it on the sample. Now, if we are making any experiment on the sample, based on the output of that test which we are performing on the sample, we have to infer on the population. For example, now this particular vaccine, after the clinical trials come out to be as successful, okay, let's suppose 80% of the time in all the clinical trials it passed. Now I'm making a decision as a decision maker. I'm saying now this particular vaccine is suitable for the entire population, right? I'm saying now it can be given to the entire population, India population or the country. Okay, so you can relate it to that COVID vaccine, right? So there were certain vaccines which were only passed in certain countries. Certain countries, didn't pass those vaccines, right? So that is the overall population which can consume that vaccine. But it has not been tested on the entire population. It has been tested on the sample. Now, once it is tested on the sample, now how I can decide whether it should be given to the population? Is it like any threshold, like 80% or 70%? If it is like successful, shall I go? Okay. Or is there any scientific method? So that scientific method is known as hypothesis testing. Okay. So this hypothesis testing is all about where we will perform the test by using sample, and then we infer on the population. So hypothesis testing can be used to determine, if you read this first sentence, it can be used to determine whether a statement about the value of a population parameter should or should not be rejected. So that means if anybody is making a statement that this particular vaccine can be applied to the entire population, that is one hypothesis, and cannot be applied to the population, that is another statement. So uh, applying or not applying, these are the only two decisions, okay, which I can make. Okay, either to launch this vaccine or to reject this vaccine. Okay, so either of these two hypotheses, I need to prove it, through my experiment, okay, through my trials. So now I will go and perform this hypothesis. I'll take the sample and I'll perform this test. And based on this test, I will perform this hypothesis testing to prove whether this is correct or this is correct. Now, out of these two hypotheses, one would be null hypothesis and other would be the alternate hypothesis. Now, if you see that these two hypotheses, they are mutually exclusive and collectively exhaustive. So that means either you will apply that vaccine to the entire population, or you will not apply. Okay, so there is no any other grounds. Okay, for any test, either it will fail or it will pass. Okay, so that's the reason in hypothesis testing we will have only two hypotheses. One is null and another is alternate. And these two hypotheses has to be mutually exclusive. These two hypotheses should not be true at a time. Both hypotheses should not be true. Okay, if one is true, then other has to be rejected. Okay, so that's how we have to frame the hypothesis. So null hypothesis, which is denoted by H naught, is a tentative assumption about the population parameter. I will explain about this with an example. And this alternate hypothesis which is denoted by HA, is just opposite to this null hypothesis. And to perform this hypothesis testing, okay, we use the data from a sample to test whether the null hypothesis is true or whether alternate hypothesis is true. Okay, so I was talking. I'm using a lot of scientific words. This But once we look at the example, these things will get clear. Now, first thing comes for developing this null and alternate hypothesis. Now, again, take the example. Okay, now let's suppose I want to come up with a new product and I want to launch in the market. Okay, now definitely there would be some what do you say, authority, okay, or some committee which will decide whether that product should be launched in the market or should not be launched. You can take any. It can be your medicines or vaccines, or it could be even movie. Okay, so even the movie to be released or not, there is a committee which will decide, right? So let's suppose there is a product which I want to launch. Now the committee will ask me the question like, why should we approve? Now what I have to prove? I have to prove that this particular product is effective. Okay, so what is the status quo at this moment? What is the condition at this moment? Is that new product is not existing. Everything is functioning the way it is, right? So nothing changed. But if that product is launched, then there would be some change. Just think about a mobile phones. Okay, earlier the mobile phones were not there. Things were running without the mobile phones only. So that is like a status quo at that moment. Okay, if now somebody has invented a mobile phone and they want to launch it, and now there is a committee which needs to decide that whether what why this mobile phone should be launched. And now as a company, okay, or as a inventor, now you have to prove that this mobile phone will address this kind of problem, okay, of the humans, okay, of the mankind. Now that's something I have to prove. So here, when you are defining the null and alternate hypothesis, just think about it. Null means a status quo. So status quo would be okay, fine, without mobile phones. I will assume that okay, these mobile phones will not give any value to the human mankind, okay, or humans, okay, and it should not be approved. So the things will run as is. It will not create any disruption. Okay. So that is the status quo. So null hypothesis would be that. Alternate hypothesis would be just opposite to that, saying that okay, this mobile phone will bring lot of change, good change in the world and all those things. Whatever I want to prove will become my alternative hypothesis. Are you getting? So, for example, in this drug case, I'm saying drug is effective. So that will become my alternate hypothesis because that's something I want to prove that is effective. If it is not effective, then it is like status quo. It is not there. Earlier it was not there. Now also it will be not there. Okay, so that would be my null hypothesis. Okay. Now every time to prove something, I have to make sure that my alternate hypothesis is accepted. If alternate hypothesis is accepted, then only any change will happen. Okay, so that's how we have to define. So lot of care needs to be taken to structure and to define this hypothesis. If you don't define it in the first step, all your tests may go wrong. If you have just, you know, put and consider the null hypothesis as alternate hypothesis and alternate hypothesis as null hypothesis, then whatever coming out of this whole process, you will infer it incorrectly and you will take the wrong decisions. Okay. So correct hypothesis formulation is very, very important. Okay. Now, I'll give you an example also. Okay. Uh, what is this? Okay, leave it here. So for example, now example, a new manufacturing method is believed to be better than the current method. Now, somebody in the manufacturing uh, company, they have come up with a new process, saying that this new process or this method will be better than what is existing. Okay, and it will bring more efficiency. Now, my alternate hypothesis is something which I needs to prove here, saying that this new manufacturing method is better. So that would become my alternate hypothesis. Opposite would be this new method is not better. than the old method. So what will happen? So it's the same status quo will run. Okay, so what was been running? Okay, and there would be no change. So if it is not accepted, then the old method will be in practice, and the people would be using the same old method. So that would become my null hypothesis. Now here it is in the form of sentences, right? The alternate hypothesis and null hypothesis. Here we are saying new manufacturing method is better, or null is saying that new method is not better. But in statistics, we have to frame this hypothesis in a form of an equation, which can be measured and quantified. Now, this is subjective. I'm saying better. Better is what? You have to define what is better, right? There has to be some quantitative measure which you need to calculate to prove that whether that particular method is more efficient or not. For example, quality of a product. Now, if you want to prove that new manufacturing method is better, then I can prove by measuring the quality of the product which is coming out of that method. And that I will compare with the previous method. And if it is greater, then I can say that, okay, this new manufacturing method is better if the quality is greater than before. Okay. And that will become my alternate hypothesis. Okay, another example, a new bonus plan that is developed in an attempt to increase sales. Now, people have come up with a new bonus plan, okay, saying that, okay, now this will increase the sales. Now, if you give the bonus to your employees like this or to your sales executives in this way, then definitely they may work more, and they may get more sales, okay, and that's how you can increase the sales. Now, how can I take a call? Now, there is a committee who has to approve this bonus plan. Now, they will perform this hypothesis testing, where the alternate hypothesis would be a new bonus plan is increasing the sales, will increase the sales. Okay, and the null hypothesis does not increase it. If the null hypothesis is accepted, then again it is the same status quo. Okay, the old bonus plan will work, and the way it was working, the same way it will work. Okay. If there is alternate hypothesis is accepted, then they will change the old bonus plan with this new bonus plan because it has been proved that this new bonus plan is effective and it will increase the sales. But as I mentioned, now this hypothesis, just for our understanding, I put it as a sentence, but when you have to perform the statistical test, it has to be quantified and it has to be in the form of an equation. Okay, not equation, it has to be some numeric measure which you have to use, to prove whether this alternate hypothesis is should be accepted or should be rejected. Okay, so when I'm saying increase sales, then probably now the sales could be that measure. Okay, if the sales is greater, by using the new bonus plan when compared to the old bonus plan, then I can go with this alternate hypothesis. Okay, few more example. A new drug is developed with the goal of lowering cholesterol level more than the existing drug. So here the alternate hypothesis. Now here we are comparing. Okay, saying that this new drug is better than your uh, existing drug in terms of lowering the cholesterol level. So alternate hypothesis is that yes, it is more effective, and the null hypothesis is that it does not. It cannot. It is not that effective as the older drug. So is this clear, guys? Did you get an understanding how to develop the null and alternate hypothesis in a
Yes,
simple
sir.
term? Whatever you want to prove that you can mark it as an alternate, okay, which is something new, okay, which may create a disruption, which may bring a change in the existing process, that will become your alternate hypothesis. And the status quo, the way it is running now, okay, the way the things are running, the same way if you want to run it, then that becomes your null hypothesis. Okay, now let's get into a little bit in a quantitative let's frame this in a quantitative way now. Now, for example, the label on the milk bottle states that it contains 1,000 milliliter. Okay, now let's suppose there is an audit guy, okay, he has to go and test this. Okay, whatever now this business or this company is claiming, saying that okay, this milk bottle contains 1000 ml of milk. Okay, now there is one committee which needs to prove whether this person is correct or this person is wrong. Okay, so here the null hypothesis, now this you understand is little tricky. Okay, you need to understand. Now this person, this company, they are saying that it is contains 1000 ml. Okay, so that is a kind of a state at which this company is now. Okay, so it is saying that it contains 1000 ml. Now as a auditor, guys, just a second, I'm getting a call. Just give me a moment. Okay. So now this particular company who is claiming that okay, this bottle contains 1000 ml. Okay, the same thing will be there, if this particular auditor or this committee cannot prove that okay, it does not contain this much quantity of milk, right? So here the null hypothesis would be that the average quantity in the bottle is greater than or equal to 1000 ml. See, if it is greater, then it's fine, right? Because he's selling more quantity, okay, in the same price. But it should not be less. So, as a auditor, as a steering committee, or as a quality inspection guy, my thing is that it should not be less. Whatever you're claiming, you have to abide to that. Okay, you should not sell less quantity, less than 1000 ml. So what I want to prove here as a auditor is, or as a committee, is that I want to prove that this particular bottle contains less than 1000 ml. So what is my interest here to prove is to prove that this status quo which is company is following is wrong. Okay. And here I will consider that it should be that it is less than 1000 ml. Now see, there could be another way of framing this. So you can say that it is whatever they are saying that is correct. Okay. And I have to prove that it is incorrect. This could be also in one of the hypotheses. Okay, so we'll talk about one tail, two tail test. So here for now, let's suppose my interest is only to prove that okay, the quantity is less than 1000 ml, what this company is claiming. So here my alternate hypothesis would be only at one direction, that this average, okay, average, because see, I cannot take sum of it, right? If I'm going and checking every bottle, so in some bottle, okay, it is 1000, some bottle it is 900, some bottle it is 1200, right? So I'll go with an average. Okay, and you know why we go with average, right? So average is the indicative measure, for the entire data, right? So I'll go with a population mean, saying that okay, overall, on an average, the bottle contains milk which is less than 1000 ml. So this is something I want to prove, and that becomes my alternate hypothesis. And as I mentioned, this alternate hypothesis and the null hypothesis, they are mutually exclusive and collectively exhaustive. Just opposite to this will become my null hypothesis. So what will be opposite to this? It would be greater than or equal to. Can you get any other uh, scenario apart from these two? No, right? Either this mean could be less than 1000 ml or could be greater than equal to 1000 ml. There is equal to also, right? So there couldn't be any other scenario apart from these two, which will fall in either of these two scenarios. Now, in that way, I can I can validate that my null hypothesis and alternate hypothesis are correct because they are not, they are mutually exclusive at the same time, they are collectively exhaustive. These two events cannot occur together. Okay, so that you have to test it. So now this is how I will uh, frame and develop my null and alternate hypothesis. So just let me know if this part, this example, and this framing of null hypothesis and alternate hypothesis is clear to you guys or not.
Yes, sir, it's clear.
Yes, sir.
Okay. Now, now for this, what we will do, what you will do. Let's suppose you have to go and test this. Okay, and you as a auditor, okay, you have to go and audit whether whatever this company is claiming, whether that is correct or not. Now, let's suppose this is the alternate hypothesis which you have to prove. How you will go and do the auditing? And if this alternate hypothesis, let's suppose it has come true, then you can go and sue that particular company, saying that okay, whatever you're claiming that is not correct, and you've been selling milk which is less than 1000 ml, and you're fooling the customers, right? But how you will go and test this? As you mentioned, for testing, you will go and take the sample, right? You cannot go and pick every bottle, whatever they are manufacturing, you will go and test and you will go and measure the quantity, right? It is not feasible and it does not make sense also. For any audit auditor, whether it is a financial auditor or quality analyst or whatever, they generally pick up the sample only. Okay. So here also, we will take some samples of bottles. Okay, and depends like, okay, so as I mentioned, the sampling is very important here. You have to make sure that you are picking in your sample, the objects are being picked at multiple time period from multiple locations. All that thing is there. You have to make sure so that your sample is representing your entire population. So once you pick up the sample, on the sample, you will go and measure. And here in this case, I will measure the quantity and then finally I will calculate the mean of it. Okay, I will take the sample mean, and that sample mean I will compare with this 1000 ml. Now it is as simple as just going and let's suppose in my sample average is coming out to be 1200 ml. So just by using this X bar and comparing with this mu, is that the thing I need to do? Probably not. Okay. So here we will not just compare this number with this number. There is a mechanism, there is an approach. We will also consider the variance. Because why we can't just take this sample mean and compare with the population mean? Because in my sample, there could be a scenario that there I may get some extreme values. Let's suppose I have a sample of 10 bottles. In 10 bottles, let's suppose in 9 bottle, the quantity is 800 ml only or less than 1000 ml. But there was one bottle which is filled up, and it has 1500 ml. If you take an average, it may give you 1000 ml. Is that correct? If you go and say that, okay, no, you're following whatever you are declaring, that's correct. It's not, because in your sample, 90%, more than 90% of the time in the bottles, the quantity was less. There was only one bottle, which you got where the quantity was higher. Okay. And based on that, your average, and you know that mean is sensitive to values, right? So I cannot just take the decision based on the sample mean. I will also consider the variance. Variance means how these values are varying from the mean. I will consider that also, and based on that I will go and perform this testing, and then I will go and select I will and then I will take the decision whether I have to go with null hypothesis or the alternate hypothesis. Now the again one more thing will come into picture, right? How confident you are in terms of accepting or rejecting these hypotheses, right? Because see, anyways it's a sample, right? It's a sample. You could be wrong in terms of selecting the sample also. So definitely there would be some kind of a sampling error. And if you remember, with the sampling error, we discussed about that confidence interval, right? So confidence interval is giving a kind of a range, okay, by which you are minimizing the sampling error. You are saying that in this particular range it may fall, your mu. So the same way here also, when I'm testing and when I'm uh, accepting or rejecting any kind of an hypothesis, I have to also provide the confidence level. In this case, for example, if I go and say that with 95% confidence level, I'm saying that okay, your alternate hypothesis is true, then whoever is the decision maker, he will accept my verdict. Okay, if I'm saying, if by 85% I'm saying that this is true, probably he may not accept my verdict and he may say that okay, no, I cannot accept your hypothesis. Okay. So based on this confidence level, this hypothesis testing um, output may differ. Okay. So for example, for the marketing kind of scenarios, there I can go with this alternate hypothesis at 85% confidence level on. So for example, in the marketing, okay, like bonus plan. For example, the bonus plan, if at 85% you say that, okay, this bonus plan would work and increase my sales, I'm ready to take it. Okay, at 85%, if you prove that this alternate hypothesis is true, probably your business may accept. But 85% confidence level, if you are going and telling to the life science company that this drug is more effective, probably they may not accept your hypothesis, right? So it differs from industry to industry at what confidence level you are accepting and rejecting these hypotheses. So now I've talked about multiple things. I talked about sample statistics where like mean, okay, based just based on the mean, we don't take this decision. We also infer to variance. So, and again, we also consider the confidence level also in terms of accepting or rejecting the hypothesis. Now, too many things we have discussed. Now, let's talk one by one in detail and then understand this entire approach step by step. So, first step is like, first we have to frame the hypothesis. Okay, as I mentioned, it has to be in a quantitative term. Okay, that hypothesis you need to frame. Now, I'll just take the previous use case only where the customer or the company is claiming that okay, they are maintaining this much quantity in their milk bottles. Okay, and now as a quality inspection person, my trial would be, to prove that as incorrect. Okay, otherwise what's the purpose of doing quality inspection if I want to prove that he's correct? Okay, then what's the point of doing? So whoever is the quality inspection guy would be, his purpose would be, to prove that there is a problem. Okay. So now this would be my status quo. Status quo in the sense, whatever the company is claiming, that is correct. And I have to prove as a quality inspection guy that that person is incorrect. Now, it could be one-tailed. Okay. Either I may say that, okay, this mu is less than 1000 ml just now. Okay, what we have seen. Okay, or else my intention would be to prove that no, it is greater than 1000 ml. Okay, or else I may have to prove that okay, that this is not equal to 1000 ml. It may be less or it may be greater, but it is not exactly 1000 ml. So here I may go ahead with different hypothesis which I need to prove. So firstly, I will frame my alternate hypothesis, what I want to prove. Okay. So if it is like something like this, okay. So this is something what they are claiming, and this is the true population mean. Okay. So this is something what he is claiming, saying that, okay, in my entire population of my milk bottles, every bottle is capturing or containing 1000 ml. So my average bottle quantity is 1000 ml. So this is, you can call it as hypothetical or uh, or a pseudo population mean, okay, which this guy is claiming for. And this is my actual mean, actual population mean. So actual population mean, definitely it is hard to capture. So instead of this actual population mean, I will go with the sample mean, which is X bar. And what I'm saying, what I want to conclude here is, I'm saying that this actual population mean is less than what exactly this guy is claiming for. If this I want to prove, now this will become my lower tail test. So if I put it in this way, let's suppose this is my normal distribution. Okay, this is my mu0. Now I'm saying my actual mu is less than this mu0. Now where it is actually falling, it is falling on the left uh, left left hand side of the distribution. Okay, and we call it as a lower tail. This side is known as lower tail, this side is known as upper tail. Now if I want to prove that this actual mu is less than your mu 0, now this will become my lower tail test. If I want to prove that this particular actual population mean is greater than mu 0, now this will become my upper tail test. Here the alternate hypothesis would be actual population mu is greater than mu 0. Now if I have to prove this, where I'm saying this actual population is not equal to mu 0, then my actual mu may fall on the left hand side also, or on the right hand side of this mu 0, right? So then it becomes a two-tail test. Either it may fall this side or it may fall this side. Now, like this, I will first frame my alternate hypothesis based on what is my objective, what I want to prove. And just opposite to this alternate hypothesis will become my null hypothesis. So if my alternate hypothesis is mu less than mu 0, then my null hypothesis would be mu greater than equal to mu 0. So same case here. If my alternate hypothesis is greater than mu 0, then here it will become less than equal to mu 0. Here if it is not equal to mu 0, then here it will become equal to mu 0. So in that way, I have to first define my hypothesis. And I have to make sure that these hypotheses are mutually exclusive and collectively exhaustive. Okay. I'll take a pause. Let me know if you have any question. Is it clear? Guys, till this part, is it clear?
Yes.
Okay. Fine. So let me proceed then. Let's take an example now. The people who are not clear, now probably you will understand this. Now, for example, a major hospital in Chennai provides one of the most comprehensive emergency medical services in the world. Okay, so they are claiming that we are the best, right? And they are saying that they operate in a multiple hospital system with approximately 10 mobile medical units, and the service goal is to respond to medical emergency with a mean time of 8 minutes or less. So what they're claiming? They're saying that whatever medical emergency comes, they will service it within 8 minutes. That is 8 minutes or less, right? So the director of the medical services wants to formulate the hypothesis test that could use a sample of emergency response times to determine whether or not the service goal of 8 minutes or less is being achieved. Now they are claiming that, okay, they will serve within 8 minutes. Okay. Now that is the status quo which they are following. That is something, okay, which is there and everyone is following that. Everyone is not following, everyone is accepting that. Okay. Now, as a director of medical service, now you have to test it whether is that true? Is that SLA is less than 8 minutes or not? Okay, that's something they have to prove. So what is now you tell me what would be the null hypothesis here? Or tell me what is the alternate hypothesis? Anything is fine. Okay. So here I'm saying just you need to concentrate on this mean time of 8 minutes or less.
Alternate would be 8 minutes or less.
Alternate would be 8 minutes or less?
We have to prove that it is 8 minutes or less, right?
No, no, no. This is the status quo, right? So here you have to, here is the catch. Here the hospital is saying that they are following 8 minutes or less. Here, what is the need of the test now? The need of the test is to prove that this is incorrect, right?
Okay.
Otherwise, it is the status quo. They are saying 8 minutes or less. Nobody's questioning. Everybody is accepting that, right? But why this director wants to formulate a hypothesis test? He wants to make sure that basically why the test is happening, whether this is incorrect, right? So that would be the objective of this test, to prove that okay, this claim, whatever the SLA they are mentioning, that is wrong. Okay, so here I have to state that this is greater than 8. And see here why I said that okay, frame the null hypothesis, because it is clearly mentioned that okay, mean time is 8 minutes or less. So that means they are claiming that it is less than or equal to 8. So just opposite to that would be my alternate hypothesis. Clear?
Okay.
Now I will take the sample. So here they are saying I'll go and take the sample of emergency response times. Let's suppose I take 10 emergency cases. I'll take those randomly, I'll pick those emergency cases and I'll see that how much time they have took, to respond. Okay, whether it is 8 minutes or less than 8 minutes. Okay, and that would be my sample mean. And we will discuss later, like, what all methods we will follow. But for now, just understand how we have to formulate these hypotheses. Here, somebody is claiming something. There, that particular company, they were claiming that, okay, they are maintaining 1000 ml quantity. Here, this particular hospital, they are claiming that, okay, they are maintaining this SLA of 8 minutes or less. Now, what's the purpose of this test? To prove them wrong, right? So that will become my alternate hypothesis. Clear? So see now here the alternate hypothesis greater than 8 and the null hypothesis something what they are claiming for. See, I will not prove whatever is currently existing. I have to prove which is, as I mentioned, which is disruptive, which will change that status quo. That is something will become my alternate hypothesis. Now, this hospital is already claiming that. So that is the status quo they are following. And everyone has accepted. And this is something they are very boldly, they are going and telling, they've been telling that, okay, they are following this much of response time. They are saying that, okay, we are the best in the world and, we are very quick. Any emergency, we will respond within 8 minutes. So that is there. Now, why the need of this test is to prove whether whatever they have claimed is correct or not. Got it? So here, the null hypothesis, the emergency service is meeting the response goal, no follow-up action is necessary. So if it is come out to be this, then I will not take any action, this particular director, okay? I mean to say director of this medical service, he will not take any action. If it has proved that this alternate hypothesis is true, then the emergency service is not meeting the response goal and appropriate action will be taken or is required. Okay. Now, what does this mean? Mu? Mu is the actual population mean. Population means population. This is something like hypothetical you have to think about. Like overall, whatever medical emergency cases have come in, okay, on the average response time is greater than 8 or less than equal to 8. That's the kind of hypothesis you are making. And to prove those hypotheses, you have to depend on the sample. You cannot go and collect the data for entire population. In this cases, hospital cases, probably it would be you can go and collect the entire data. But if you want to make it quick, then you just pick up some sample and then you can perform this hypothesis testing and you can take the decision. Now let's understand what is this type 1 error and type 2 error. Okay, so I will show you with this particular diagram. Okay. So what could be the error, guys? Now see, here I have two hypotheses. One is null hypothesis, one is alternate hypothesis. Okay, so let's suppose in reality, my null hypothesis is true in reality. But with this hypothesis testing, let's suppose I have rejected that null hypothesis. So for example, in this case only, whatever that hospital is claiming in reality, which is again hypothetical, in reality, whatever they are claiming, that is really true. But probably I've taken a sample which is not right or something, went wrong, and I rejected that hypothesis. Now that is one error, right? That is known as type 1 error. Okay. Second error would be that null hypothesis is not true. Whatever they're claiming, that in reality that is not true. But through my experiment, I basically I accepted that null hypothesis. I'm saying no, this company is falling. Again, that would be my error, right? So that is known as type 2 error. Now to understand better, let's take this particular scenario. Okay. For example, there is a court case. Okay, there is a judgment which the judge needs to make. Okay, and there is a culprit. So let's suppose it's more of a murder case. So now there is hypothesis. Now it's tell me what would be the null hypothesis here, guys, in this kind of a scenario where there needs to be the judge needs to take a verdict, and there is a culprit, okay, who has been caught for a murder case. Now, what would be the null hypothesis here? What is the status quo?
That the culprit murdered.
That is the status quo. What exactly the judge needs to prove, or the advocate needs to prove? The lawyer has to prove he's guilty. See, what is the status quo? That case has come now, okay, but before the case, he was innocent only, right? Now also he is innocent only. Until unless you will get a sufficient evidence till that part, he will be innocent only. So now this is the confusion, guys. You guys are getting confused. So null hypothesis is all about the way it is earlier, the same way it will be now. So the guy was earlier innocent, that person. So it will be innocent now also. So that is the null hypothesis. So null hypothesis says that that person is non-guilty. That person is innocent. And the alternate hypothesis, why that case? Why they are fighting that case? They are fighting that case to prove that this person is guilty. Otherwise, what is the need of that case? Now that is something we need to prove. That will become my alternate hypothesis, that that person is guilty. Now, how the judge will make a decision? Now he will ask for the evidences, right? So all the possible evidences may not be possible. Not be possible. So they will take some important evidences. And that is nothing but you can consider it as a sample. And based on that evidences, now this judge has to pass the verdict. Now, just look at here. Okay, now this is the reality. In reality, let's suppose that person is really innocent, but the person, whatever evidences have been produced, possibly, those evidences has went against this particular person. He's a pretty guy. Okay, actually, he has not committed the murder, but somehow this judge, by looking at the evidences, he has rejected the null hypothesis. He said he rejected that he is not innocent and he has found guilty. Okay, then what is the error he will make? That would be the type 1 error. If the person is innocent, but he has considered as non-innocent. Okay. Second error is actually he has committed the murder. Okay, he has done the murder, but there is no enough evidences to prove he is guilty. Okay, in that way, again, the judge can make an error which will considered as a type 2 error. In this case, he will be considered as innocent. Okay. Now tell me, these are the two errors in this scenario. Now you tell me which error would be more critical, type 1 error or type 2 error. Type 1 error is where the judge is considering him as guilty, but he is not guilty. Type 2 error is the person is guilty, but the judge is saying is not guilty. These are the two errors. Now you tell me which error is more critical.
Type 1.
Yes, type 1 is more critical. See, what is this type 1? Something is like running. Okay, something is already in the status quo. It is running fine. You are suddenly you have come and you have made some disruption. You said that okay, this will work, that will work, and you have invented some new product, new process, new process. Something you have invented, and you are saying this will work. And if I say that, okay, that will work, this new product, and I am changing the whole thing, and if in case, in reality, if that product is not effective, or if that process is not effective, I'm kind of taking a very big, I'm making a very big mistake. So in that way, type 1 error is a big mistake. Type 2 error is, okay, even if that new process is effective, if I rejected it, but still that status quo is still maintained. I'm running the way it is. Okay, it will not harm me that much. Okay, so in that way, the type 2 error is relatively less impactful than the type 1 error. So in this case, also like persons and in statistics books, this example they will give. If I am hanging, if I am hanging a innocent person, that is a bigger mistake compared to a person who is guilty and freeing him. Okay, because i'm I'm making a big sin by uh, hanging somebody who is not guilty, right? See, somebody has done a mistake, okay, I'm freeing up, still that is fine. But somebody innocent person, if I am punishing him, that is a bigger mistake. So that is how, they have explained in the books, like, how you can, um, to prove that this type 1 error is more critical than the type 2 error. Okay. So if you are accepting H naught, when H naught is true, that is the correct decision. You need not to worry. You are safe. You have made the right decision. If H naught is false and you have rejected the H naught, in that way also you are fine. You have made the right decision. But if you go wrong, then either you will make type 1 error or type 2 error. Okay. So in this case, type 1 error is considered as a more significant error when compared to type 2 error. And we'll see that, how we can minimize this particular error when we are making the decision out of this hypothesis testing. Okay. So that's something, okay, we will discuss tomorrow. Okay. And there are basically three approaches. So we will talk about these three approaches: p-value, critical value, confidence interval value. Confidence interval we have already discussed. Now it would be relatively very easy for you to understand that particular approach. And apart from that, we will talk about other two approaches.
So
Once we
Shiv,
understand, yeah,
the type 1, type 2, is it like, that law says that allow 100 guilty person to escape, then, one innocent to be hanged or something
right,
like
right,
that.
right, right. Yeah. So this is how we understand like which error is more critical. So see, in the business terms also, okay, um, in our real life also, let's suppose your life is going smoothly and somebody suddenly will come to your life and say that, okay, you change your life like this and everything will be fine and all, and you will do all those things, and it will not work, okay, and you will get into a different mess. Now that is much more harmful, right? Even sometimes, for example, somebody will come to you and say that, okay, invest this much amount and it will double, okay, and you will invest and you will lose entire money. Okay, so that is much more dangerous when compared to, let's suppose there is one genuine guy who is coming and saying that, okay, yes, you invest and your money will double, and you will say no. Fine, that is okay. But still, there is no loss. There is no loss, no gain. So that is not that harmful, that type 2 error. When you are rejecting something, okay, which might be impactful. But here, if you are rejecting your status quo, your null hypothesis, and you're going with your alternate hypothesis, and if that alternate hypothesis goes wrong, then you are committing a bigger mistake. Okay. So this is just to prove that type 1 error is much more critical than your type 2 error. And when we are talking about those three approaches, we'll see that how this type 1 error is taken into consideration while making the decision. Okay. All right. Any questions? Guys, tomorrow I will inform you. My company's CEO is in town. Okay, so I may have to be at office early tomorrow. So I will inform you guys if I'm not taking the class tomorrow. If you need anything to be discussed, then I may request Vikrant, to take the class tomorrow. If you have any topic to be discussed, just put that into the Telegram channel, and Vikrant will cover that topic again. Okay. So I will inform it's not any meeting has not been set in the morning, but usually, he comes early to the office, so we have to be at office. Okay, so if there is no meeting, I can take the class from office. But if there is any meeting, then I have to cancel, or I may ask Vikrant, to take the class. We'll inform you. Okay. All right then, guys. Thank you. Have a nice day. Take care. Bye.